In this video, we're going to look at the basic concepts of probability and counting. Let's start off with some basic definitions first. So what is probability? Probability is the likelihood of an event occurring. To see what this likelihood may be, we perform probability experiments, where through trials we find out the results. From here we could have outcomes, which are the single trials within the experiment. And through all of our experiments, we should be able to create a sample space, which tells us what are all the possible outcomes that could occur within our experiment. Then lastly, within our sample space, we have what are called events. And these are just subgroups of our sample space. So maybe we're looking at something more specific within our sample. For example, let's say we have a six-sided die. The sample space would be the six sides, 1, 2, 3, 4, 5, and 6. Whereas if we're talking about an event could be the opportunity of rolling an odd number. That's a subgroup of the entire die, because that's only the numbers 1, 3, and 5. Whereas if we talk about an outcome would be the specific side we roll, in this case 5. So it's like an example of how a tree diagram could help us with looking at the sample space. So say we toss a coin and then we roll a six-sided die. So step 1, we flip our coin. We have options of heads or tails. So we're going to label that first. Step 2 is that we could roll one of 6 options with our die. Now that can happen here either if we roll heads or if we roll tails. So we have to look at it as we first roll heads, then we have these 6 options. If we roll tails, we have these 6 options. So if we look at all our options, we could do heads and then a 1, heads then a 2, heads then a 3, heads then a 4, heads then a 5, or heads then 6. Under the tails, we have the same options, but with tails 1s, tails 2s, 3, 4, 5, and 6. So this means that our sample space is all these options that could occur. Whether it's when we flip it, we get a heads first, or whether we get a tails first. Now one item that may be very helpful for us is the fundamental counting principle, which says if we look at our 2 events, or it could be more than 2 events, but if we take the number of ways the first event can occur and the number of ways the second event can occur, and we multiply them, that will give us the total number of ways the 2 events can occur in sequence. So let's go back to the example we just had. If I start by flipping a coin, I've only got 2 ways that can happen. It's either heads or tails. If I look at rolling a die, I've only got 6 options because it's one of the 6 sides. If I multiply them together, I'm going to get 12 total options. And if I looked back at my tree diagram in my sample space, I had 12 specific options that I found. Now this one, say I have a 3-digit code that uses the numbers 0 to 5, and I want to know how many options there are if no digit can be repeated. Okay, so we think about the first time we enter in our digit, we have options 0 to 5. That's 6 total options. Now when we enter our second digit, 1's already been used, so we can't use it again. That leaves us with 5 options. And then we go to enter that third digit, 2 have already been used, which leaves us with 4 options. So if we look now, we have digit 1 has 6 options, digit 2 would have 5, digit 3 would have 4 options. So if we want to know the total number of options, we just multiply the 3 together and get 120 total options for a 3-digit code using the numbers 0 to 5 and not repeating. Now we could actually go through and list all of them, but for now we just want to know how many there are. Now let's start to actually get into probability beyond just counting. Some basic notation you're going to see throughout this video is we have capital P, which stands for probability. Events are going to be labeled in capital letters. So if I say P parentheses A, I'm saying it's the probability of event A. Now it's also important to recognize, what do probabilities go between? Probabilities are always between 0 and 1 inclusive, so that means I can have a probability of 0, I can have a probability of 1. And what does it mean? If I have a probability of 0, that event is impossible to occur from my sample. If I have a probability of 1, that means it's going to happen every single time. It's going to happen. And then you have in between with 50 or 0.5 being a 50-50 chance of something occurring. Now we have several types of probability. One of those is subjective probability, and that's using intuition or educated guesses or estimates to come up with a possible probability. A place we often see this is in the medical field, where a doctor may look at some different things about a patient and say they have a certain percent of recovery. For instance, this one says a doctor may feel the patient has a 90% chance of full recovery, but they can't be, they're just using their intuition and educated guesses to determine that. We're going to avoid this type as much as possible. Instead, we're going to look at two different types. The first one's called the classical or theoretical form of probability. With this, each outcome in the sample space is equally likely. So every single instance has a chance of being pulled out at the same time. And if we want to know the probability of a specific event, we just take those number of outcomes of the event and we're going to divide it by the total number of outcomes in the sample. So let's look at this problem. If I shuffle a deck of cards, what is the probability of selecting a red king? So the first thing I want to do is say, what's the total number of outcomes I can have here? Well, I have 52 cards in a deck, so I have 52 outcomes. The next thing I want to know is, how many red kings are there? Because that's how many of these events occur. Well, in a deck I have 2 red kings. They're King of Hearts and the King of Diamonds. So if I want to know the probability of getting a red king, it's going to be my number of outcomes of the event over my number of samples, or my outcomes in the sample. So that's 2 over 52, or approximately 0.0385. Another type is called the empirical probability, also known as the statistical probability. And this is based on observations that we get from probability experiments. And there's nothing to say that each of these observations are equally likely, which is where the difference is. So for this one, I take my frequency of a specific event over my total frequency to get that probability of the event. So let's look at another example here. So say we go back to the motor vehicle occupants killed in crashes that we've used before. And I want to know, what's the probability that someone died in a motorcycle accident? Well, I know that the frequency, the total frequency, if I add up all of these, is 37,594 deaths in 2005. Then I know that my frequency for motorcycle deaths was 4,553. So if I want to know the probability of a motorcycle crash causing a death, I just divide my motorcycle by the total and get that's about 12 hundredths, or 12%. Some other concepts that are important to recognize. There's one called the law of large numbers, which says that if I continue to repeat an experiment over and over again, my empirical probability should come out to be the same as my theoretical probability. One place you can see this is especially with flipping coins. If I flip heads and tails, now I could start off flipping a coin 5 times and get tails 5 times in a row. But as I start to increase those number of flips, say to 500, 1,000, 5,000, my probability should come relatively close to 0.5 or 50%, because I have an equally likely chance of landing heads or tails if I have a standard coin. The other idea here is the complement of an event. The complement is the set of all outcomes that are outside of that specific event. So it's those that are not included in the specific event. And we can use some different formulas to help us figure out different probabilities. We know that if we take an event plus its complement, that should add up to 1, because the total probability should equal 1. If I want to find just the probability of an event, I could always do 1 minus the probability of the complement. And conversely, if I wanted to find the probability of a complement, I could do 1 minus the probability of the event. So let's look at some examples of this. Let's go back to the vehicle crash example. Put in the relative frequencies here to help us out. The relative frequencies relate to the probabilities. That's what this is representing here. So I want to say, what's the probability of dying in a vehicle other than a truck? So I know the probability of a truck is 0.37 from my relative frequencies. So I want to know, well, what's the probability of everything else? I could always do 1 minus that probability, because not dying in a truck would be its complement, and get 0.63. Say I want to know what's the probability of dying in a vehicle other than a truck or a motorcycle. Well, I have to first say truck or motorcycle would be these two, which is the 0.37 and the 0.12, which gives me 49 hundredths. So if I'm looking at the probability of everything else, I would do 1 minus this probability, which is 51 hundredths.